photoelectric effect describes the effect caused when electromagnetic waves hit a metal surface, which can cause electrons to be released from the metal surface. These electromagnetic waves can be thought of as photons. Photons are small packets of energy which hit the metal surface. Each one has the potential of releasing an electron. If we decrease the wavelength of these photons, this has the effect of increasing its frequency, which also has the effect of increasing the energy of these photons. You will notice that as we get to a certain point, electrons start to be released from the metal surface. As I continue to increase their energy, the electron's energy also increases. So this graph's showing us that the energy is proportional to the frequency of these photons hitting. If we gradually decrease the energy of the incoming photons, there is one point where the electrons stop being emitted. At this point, the energy of these incoming photons are called the work function of the metal. It's the point where electrons are just released from the surface, but then have no excess kinetic energy. Anything bigger than this releases electrons. Anything smaller than this stops electrons being emitted. Different metals have different threshold frequencies. If I change the metal, we can see that the energy where electrons start to be emitted is slightly different. Notice that this one has a much higher frequency and therefore much higher energy to release electrons. So copper has a bigger work function than sodium. If I change the intensity of our incoming photons, we can see that this has the effect of increasing the number of photons hitting the surface, which also increases the number of electrons being released from the metal surface. Notice here that the energy of these electrons does not change. So intensity does not affect the energy of these released electrons. It just changes the number of electrons being released.